Factoring trinomials, quadratic functions when our quadratic function is in the form of ax squared plus bx plus c, but only when a is equal to 1. So the most important factor in this is where a is equal to 1. So in other words, this equation becomes x squared plus bx plus c. Or we might have maybe other letters. We might have a y squared plus some kind of a by value plus kind of c, where the squared variable has really the number 1, or really no number, in fact, in front of the x squared or the y squared or the a squared, whatever variation of the quadratic function you have in your question. Factoring quadratic expressions. Okay, so what we're going to be looking at is factoring trinomials. That's really, okay, trinomials, 3 terms. Okay, so 3 terms. And our 3 terms here, we're going to look at how do we get those 3 terms? Well, we've expanded by multiplying binomials. So we were multiplying binomials. And what we were doing to multiply binomials was we were doing a process called FOIL. So we were doing the first with the first with the outer, the inner, and then the inner with the last. And so we were expanding that to get the following expression: x squared plus 6x, 6x plus 4x plus 24. Okay, and then of course we were simplifying and we were getting such a trinomial. So here's our trinomial. Okay. Now, when we're asked to factor, we're asked really to go in the opposite direction. So we were asked really, if we're asked to factor a trinomial, we're trying to get our answer in this format. If we're asked to expand, we are asked pretty much to get to that format. Okay, so when we're factoring, we're trying to figure out what are our sets of binomials that we multiplied together. Okay, so they go back and forth. Now, to do this, you need to do something called a sum product rule. Now, the product of numbers here is what we call 24. Okay, and we'll see the meaning of the product or this number here, how important it will play in our steps in just a moment. And the sum of the numbers is 10. So what's going to be important is what we call the sum product rule. So what we're trying to do is we're going to try to find 2 numbers that multiply to this, or should I say, let's not say it that way, 2 numbers that multiply to positive 24 that add up to positive 10. So that's the product. Product, we multiply, sum, we add. Okay, add or subtract, depending on what the situation is. So we're going to factor the same question. Okay, the same question that we had here. We are going to go from this step here to that step. That's really what we're going to be showing you with the upcoming slides, and then we're going to do a couple of other examples. Okay, so we're going to factor x squared plus 10x plus 24. Notice that our a value, okay, the number that's in front of our x squared is 1. So our a value here is what we call equal to 1. So when factoring any trinomial such as the following, quadratic function, mind you, okay, we want to make sure our trinomial, our quadratic expression, is in the form of ax squared plus bx plus c. Okay, and it already is in our example. So we have x squared plus 10x plus 24. So in our example above here, our a value is 1, our b value is 10. Okay, so our a value here is 1, our b value here is 10, and our c value is 24. So we're going to need to know that bit of information in order to continue with the next steps. So when factoring such quadratic functions, we use something called the sum product rule. Okay, so the sum product rule, multiply your A and your C value of your trinomials. In this example, remember our A value, okay, is 1. Okay, so and really it's going to be negligible when we're trying to find the actual product rule and state what our B value is. So here, as we said, our AC value we multiply, but because our A value is 1, we don't really worry about it. We multiply it by 24 to give us 24. And that was what we saw in one of the earlier slides where we said we find the product of 24. Now we state our B value. Our B value is positive 10. And we want to keep the sign just because it's going to be very important when we do find the sum of the two numbers. Okay, so we have the numbers 24, we have the number 10. So to continue with the sum product rule, we're going to find those two, we're going to try to find two numbers that multiply to our AC value. And those same two numbers must add up to our B value. Okay, so in other words, we're trying to find two numbers that multiply to 24 and those same two numbers that add up to 10. Okay, so in other words, we want to find all multiples to our AC value, which in this example here is 24, and find which will add to the B value. So we think about all the different multiples of 24. Well, we have 1 times 24. We have 2 times 12. We have 6 times 4. Okay. We have 8 times 3. So what we're trying to do is we're trying to figure out which one of these multiples, okay, these all equal to 24. But which ones we figure out by using either positives or negatives that will give us the number 10 when we add these same two numbers. So if we look at it, obviously we cannot add these two numbers. Obviously we cannot add these two numbers. But we look here. If we keep 6 and 4 positive, when we multiply them together, we get 24. Okay? If we, as we said, if we keep them positive, 6 plus 4 will give us our 10 value. Okay? So that's really what we're trying to do. We're trying to find multiples of our AC value. And our multiples here happen to be 6 and 4. Because if we can use 6 and 4 again, we add them, we can get our sum of our value here in our quadratic expression. So let's using these values in our set of binomials. Okay, so there we have it, positive 6 and positive 10 here in the corner. Using that, open up a set of brackets, and the first term in each bracket will be the square root of the first terms in your question. So what does that mean? Okay, I know it sounds like a tongue twister here. So here's our expression: x squared plus 10x plus 24. Okay, so we've opened up our set of brackets. Okay, so here are our set of brackets that we've opened up. Because really, when we factor quadratic expressions, okay, we get pretty much two sets of binomials. Binomials meaning two terms. Okay, so we're going to have two terms in each one of these. Now, if we look at this explanation, it says, so the first term in each one of these brackets, so the first term that we're going to put in each one of these sets of brackets will be the square root of the first term. And our first term, as we said, has to be in that order, in the x squared plus bx plus c format. Okay? So we're taking that x squared, we're finding the square root of it, and we're placing that as the first term in each one of the sets of brackets. So now to finish this, and as we said, we need two sets of binomials. We need to figure out what is this second term in each one of these brackets. And well, what it is we're going to place that sum product rule values from our previous step, okay, into the sets of the binomials. So what we're going to do is we're just going to put in positive 6 and positive 4. So we're going to put positive 6, let's say, in one of them, positive 4 in the other. The order does not matter. Okay? We could have put plus 4 first and then the plus 6. Okay, and here is pretty much our answer. Now, how do we check to see if we're correct? Well, if we FOIL first, outer, inner, last, okay, this is to check our answer, we will get x squared plus 10x plus 24. Just as we just saw in the previous slide, okay, when we factor x squared plus 10x plus 24, we get our original expression, that x plus 4, and then another set of brackets, x plus 6. And again, remember, the order does not matter. Example number 2. Okay, so we have x squared minus 8x plus 12. Okay, so what we're trying to find our AC value, which is 12, our B value, which is negative 8. Okay, we take the sign that's in front of it. So what we're trying to do is we're trying to find two numbers that multiply to 12 that add up to negative 8. Okay, so what we're looking at really, what are our multiples of 12? So we have 1 times 12, we have 2 times 6, we have 3 times 4. If we multiply all those, we know we can get our positive 12. But the only problem here is we have a negative 8 for our sum. Now, what we have to do is, can we figure out a way to get this negative 8 using our multiples here? And what we do is, well, we know that two negatives multiplied together will still also give me a positive value. So negative 1 times negative 12 will still give me 12. Negative 2 times negative 6 will still give me positive 12. Negative 3 times negative 4 will still give me positive 12. So we're trying to figure out which one of these, okay, will give me a sum of negative 8. If we can't find our multiples to add up to our B value, then we have, the equation is not possible to be factored. So what we're doing here, we figure out from our values, well, negative 2 and negative 6 will give me positive 12, but negative 2 plus a negative 6, this function here turns into negative 2 positive, and a negative becomes negative 6. Negative 2 minus 6 will give me negative 8. Now, using that value, okay, we can put in now what our binomials are. And remember what we said. What we do is, well, we open up a set of brackets. We find the square root of our first term, which is the square root of x squared, which is x. So we place that as our first set of terms. And we know, because we are multiplying binomials, what is our second term. And our second term is negative 2 and negative 6. Okay? And to check this, if we wanted to check this, all we'd have to do is FOIL. First, outer, inner, last. And make sure that we get our original expression.